we were asked to find the asymptote of the function. The meaning of the word asymptote simply means where the graph will never touch. And it seems that our graph will never touch the x-axis. The x-axis is where y is equal to 0, and that will be our solution. Asymptote will be y equals 0 because this is where the graph will never touch. And now we are asked to find the y-intercept, which is r. That's what r is. R is the y-intercept of the function. We'll be given the standard form that h of x is equal to a to the power of x. Now, as we know, anything raised to the power of 0 is of course 1. So those are the coordinates that are 0 and 1. Now we were asked to find basically the equation of the function. For us to do that, we will need a point on the graph. That can provide us with both x and y for substitution's sake. So for now, we know that the function is h of x equals a to the power of x. However, our x, let me just say at point P, our x is 2 and our y is 9. That's literally all we need to do, substitute. So this is y and that's x. So when you come here, just substitute. So you got 9, you got a to the power of 2. 9 can be expressed as an exponent of, let's say, 3 squared. This is a squared. Laws of exponents: when bases are the same, so are the exponents, and vice versa. When exponents are the same, so are the bases. So it's safe to conclude that a equals 3. That means the function, or h of x rather, is equal to 3 to the power of x. Up next, we are asked to find the length of dp, given that dp is parallel to the x-axis and that dq is parallel to the y-axis. One thing we need to know about that statement is that when we say that lines are parallel to the x-axis, that is to say they share a common y value. That means the whole line will have the same y value, and of course vice versa for lines that are parallel to the y-axis. They will share a common x value. So this information, we can already see that the line dp hosts a y value of 9. That means every point on that line will have a y value of 9. And likewise, dq will always host an x value. In this case, b. So it means for us to find the length of dp, which is something like that, we will of course need the x value at d, as we already have the x value at p, which is 2. And the way to find horizontal lines will be to say the x value on the right minus the x value on the left. So let's go ahead and find the x value at d. The nice part is we already have h of x equals 3 to the power x. So basically our b is our x value, and y is 1 over 81. If we choose to express this exponentially, we could say 81 to the power minus 1, 3 to the power b. And 81 can also be expressed as a fraction, or rather as an exponent pattern. For this to have a base of 3, it can be expressed as 3 to the power 4. However, that accounts for 81, and that's also raised to the power minus 1. And that's 3 to the power b. So that will be 3 to the power minus 4 equals 3 to the power b. Again, you see the laws of exponents come into action here. When bases are the same, so are the exponents. b is minus what? 4. That means the x value at q will be equal to the x value at d. As I mentioned earlier, that's simply because the points d and q lie on the line dq. And what I said earlier was that vertical lines will share the same x value. You see that? So that means at d we now have coordinates minus 4 and 9, and at p we got 2 and 9. So for us to find dp, the length dp, we would just have to say x at p, because that's the point on the right hand side, minus x at d, as is the point on the left hand side. So dp would therefore be 2 minus negative 4, which is 2 plus 4, and 2 plus 4 is 6. So meaning for us to move from line point D all the way to point P, just need to move 6 units from D to P. I want to clarify the solution to question 4.5. We were asked to determine the values of k for which the equation h of x plus 2 plus k equals 0 will have a root that is less than minus 6. That's all extra information. What I want to emphasize is this part. H of x plus 2, the plus 2 there is a shift, and that's going to be a horizontal shift. So the function h of x had a horizontal shift of plus 2. That means it moved 2 units left. Now, since this is an exponential function, it is not really affected by horizontal movements or shiftings. It is not affected, particularly for this question, because k involves vertical shifting. You see that? So since the plus 2 only affected the function horizontally, it will not really affect the function vertically. So from this equation here, all that's important for us to understand is that h of x plus 2 is actually equal to minus k. Minus k is simply a reflection of the function. So the function we had initially looks something like this. And since it was only affected horizontally, the shape is still constant. It will not change. It will only probably move something like this. This will be the so-called h of x plus 2. However, the shape is still the same. I'm actually supposed to draw it in the same line. Pardon me. I'm actually supposed to draw it in the same line because nothing changes really. Ignore that now. My apologies. So it's important for us to understand this aspect, that the horizontal shift was just a way of trying to throw you off course. However, the most important thing here is I'd say the vertical numbers. because the y-intercept initially was 1 and your lowest known y value was 1 out of 81. So minus k is more like a reflection of h of x. So that would mean our new function slash k would look something like that. And then again, since it's just a reflection, we understand that this y value here is not necessarily positive 1 over 8, but rather negative 1 over 81. So what about k? What does this actually tell us about k? It simply tells us that k should actually be between the asymptote, horizontal asymptote, that's to say, or that is, and the lowest known point. So basically, this so-called new function minus k has to be between the asymptote, which is still y equals 0, and the lowest known negative point, negative y value rather. So it has to stay between the asymptote 0 and now the negative lowest known negative y value of minus 1 over 81.